Good morning, everybody. My name is Kaurav Kiran, and my branch is Mechanical Engineering. Today, my subject is Theory of Mechanism and Machining. Here, my topic is Dynamic Balancing of a Multiple Cylinder Engine. Here, we can observe that Introduction to Dynamic Balancing of Multi-Cylinder Engine. Dynamic balancing is essential to reduce vibration caused by engine components during the operation. Here, that one thing we need to understand that dynamic balancing is essential. Yes, it is essential because of in dynamic balancing we have number of phenomena, number of component through x and through y axis. At the same time, during that engine component, there was operations like force and the momentum. At the same time, here it involves adjusting the mass distribution and within the engine to achieve some smooth motion and proper balancing enhance engine performance, longevity, and comfort for the user. Now here we can observe importance of engine balancing. Unbalanced engine produce excessive vibration that can lead to mechanical failure. Here unbalancing engine, they may cause mechanical failure that we need to keep in your mind. And vibration negatively impact the comfort of vehicle occupieds and overall driving experience. Effective balancing minimize wear and tear on engine component, reduce maintenance cost. Here, that main thing is while we are dealing with the balancing of engine, we need to keep our mind what that was mainly wear and tear on the engine components. We need to use proper and better understanding of the components which we are using in that engine. And sorry, here types of engine vibration. Primary vibrations are caused by the reciprocation and rotating masses moving out of phase. That was the one was the primary vibration. And secondary vibration results from the imbalance in the piston motion and connecting rod. Piston and connecting rod, there was the one of the imbalance force and imbalance result is there. That was one of the vibrations in the engine that we called as secondary vibration. And tertiary vibrations are less common, but can occur due to asymmetric in engine design. Here, asymmetric means nothing but there was no same. If there is a plane of symmetric or what we call it as there is a line of action or the we can divide with some of the line we can call the axis. There was no symmetric means there is no same of that both side. But after the cutting the line, here principle of dynamic balancing. Here we can check it that dynamic balancing involves adjusting the mass and placement of engine components to counteract vibration. That was one of the what we called adjusting the masses. Here that mainly the engine components are the counteract vibration is there beyond that. And this typically requires adding or removing small masses at specific location on the crankshaft or flywheel. Both are same because of the specific and they can remove the masses on that crankshaft or flywheel. They actually can be same but different names. Some books are the crankshaft and some books are flywheel. And achieving balance involves balancing both the rotating and reciprocal masses simultaneously. Means at a time. At a time there was rotating and reciprocal masses are occur. In that the involves balancing the both conditions. And methods of dynamic balancing. Static balancing ensure the engine components are balanced when stationary. Here, the static balancing means when it is rest or we call when it is that in their own position, then we can the components are maybe balanced. That we call it as static. After that, spin balancing test are performed on the assembled crankshaft to measure imbalancing during the rotation. During the rotation, there was some of the imbalance are there. We need to put in the balance with the help of the spin balancing test and correction weightage are added or removed based on balancing measurement to achieve the equilibrium. Equilibrium means all forces are equal to zero. Now, balancing of multi-cylinder engine. Multi-cylinder engine such as four-cylinder or six-cylinder configurations have complex balancing equipment. Actually, there was some types in the multi-cylinder engine. There was like four cylinder or six cylinder. We need to put in the balancing equipment based on their own applications and own properties. And proper balancing reduce the side to side and vertical vibration specific to multi-cylinder setup. And here the one point we need to notice that techniques include using counterweight balancing shafts or specific firing order to minimize vibration. Now, balancing device and component. Counterweights are statically placed on the crankshaft to offset reciprocation masses, and balancing shaft can be added to cancel out specific vibrations modes in multi-cylinder engine. Here the last is vibration dampener and isolator further help absorb the residual vibration for the smoother operation. Exactly. Now, practical balancing procedure. Engineers perform dynamic balancing using specified equipment like a vibration analyzer or balancing machine. They can challenge and they can do their experiment based on the equipment like vibration analyzer and the balancing machine. And second point is that the engine is spoon at the operation speed, and imbalanced or identified through the measurement. Through the measurement, we can imbalance it, and corrosion weightage are then applied, and the process is repeated until minimal vibrations levels are achieved. Now, benefit of proper dynamic machine balancing, sorry, reduced engine vibrations lead to increased engine life and reliability, and improved smoothness, enhanced driver comfort, and reduced noise level. That was one of the what we called as improper comfort. And proper balancing can improve fuel efficiency by decreasing energy loss due to vibration. Due to vibration, we can increase the efficiency, but we can decrease the energy losses due to the vibration. Due to the vibration, we can decrease the efficiency also of the fuel of the cylinder. And conclusion and future tense. Once we can recall what we are learning in this session, please. Here the topic is dynamic balancing of a multi-cylinder engine. Here the introduction of this means nothing but it is the reduce the vibration of the component during the operation. We can what we call we can reduce the operations and vibration based on the component, and also it have a very smooth motion will there, and also it have the performance like comfort of the users also. And importance of engine balancing is here the main important is unbalanced engine we need to put in the balanced, because of that vibration they can maybe they can feel the mechanical failures, and also some of the impact they will negatively comfort of vehicle occupies. And types of engine vibration are primary vibration, secondary vibration, and tertiary vibration. Primary means it caused with out of two phases that are the reciprocation and rotatory mass. Secondary means this is imbalanced because of the piston motion is connecting to through the rod. We need to put it in the balanced. And tertiary vibration means it has the less common, but it is due to the asymmetric. Due to the asymmetry means if we can cut in the axis, there is no same part of above the axis and below the axis. Now, principles of dynamic balancing is nothing but we need to adjusting the masses and placement engine of the compound. That was the one of the adjusting. And also at the same time, that crankshaft and flywheel are there. No, we need to add and remove the small masses for particular location. Here we can see methods of dynamic balancing. Dynamic balancing, there is a method, different method, but static balancing means nothing. In stationary means if the cylinder is in stationary means it was totally balanced. If it is not balanced, I mean, ensure that engine components are maximum balanced. That was the static. And spin balancing test means nothing but if the what we call if the machine was in imbalance, then we need to put in the balance through the test of spin balancing test. It may be have the crack shaft also. We need to put in that, and the correction weightage are added or removed based on the balancing measurement to achieve equilibrium. Here the equilibrium, but what we call all forces are equal to zero. Or in other words, we can call some of the x direction force are equal to some of the y direction. Maybe it's zero also. Balancing of cylinder engine. There is a different type of multi-cylinder engine, like 4 cylinder or 6 cylinder. They have different application and property. We need to put the in proper balancing. It have the side to side also vibrations based on the multi-cylinder setups, and balancing device and components are reciprocational motors that we need to counterweight balance. At the same time, multi-cylinder engines have the they can add it the shaft balancing. Through that, they can out the specific vibration. A practical balancing also procedure also we saw the the benefit of this also nothing but this is the comfort and reduce the noise level. Conclusion is that a dynamic balancing remains a critical aspect of engine design and maintenance. Because of the dynamic balancing, it was very important and we need to design the maintenance and the noises level. So it was some of the good and maybe become the traits in the future. And also advanced to in conceptual methods and sensor continues to improve balancing accuracy. Through the sensor continuous, it was the balancing accuracy also, which may have contained the real-time management also have. With the last, thank you.